Hi, I'm Lyn Elkins, and in this video I shall be talking about some of the decisions that must be made for a request-reply application, and where a rules-based engine, a DevOps tool, can be of assistance, but also where they can fall a bit short. And I hope that this will be an enlightening talk about why it can take a good MQ admin several days to, quote, just define 2 queues, unquote, and some things to look for in an MQ DevOps tool. This is a really common application pattern. A request originates on a device. It could be a phone, a tablet, laptop. It really doesn't matter. It formats the query as a message and connects as a client to an MQ server. The request then flows through the MQ network to a queue on ZOS so that the query can be resolved by an existing CICS transaction that accesses a file or a database, formats the response, and sends it back. Assuming that all the queue managers, MQ servers, are in place and ignoring for the moment the non-functional requirements, you can see that this simple request for 2 queues might actually result in 5 new objects on each queue manager. And that is, of course, just the MQ piece of the puzzle. I can easily see a DevOps tool assisting with this simple infrastructure, especially for a development environment. There would be little human intervention required. But, as is often the case, the devil is in the details, or in the production environment. More than just the definitions, the wise MQ administrator has to consider the non-functional requirements that may not be required for a development environment, but will be absolutely critical for production. There isn't enough time for a more comprehensive list, but here are the big 3: availability, security, and responsiveness. What level of availability is required for this new service in production? Does the application need to serve requests all the time? If not, then the single instance model will work, but the application development team need to understand that they are introducing a single point of failure. If there is an availability requirement, then each component must be evaluated with that in mind. On the distributed platform, there will have to be multiple servers for the client connections. A minimum of 2 would be necessary. So each distributed queue manager in the configuration must have new objects defined in addition to hosting the server application. Will they use a client connection definition table or some other method to make sure that connections can be made? If using the CCDT, it must be created and distributed properly. Will the distributed queue managers need an availability solution? If so, multi-instance or a more robust solution. On ZOS, will they need shared queues? Will there be a queue manager cluster to distribute requests across many queue managers? Again, there may be more instances of object definitions required, and particular care may be needed to create connections between the now more complex queue manager network. A good DevOps tool, one that has the infrastructure baked in, can really help an administrator decide which servers are good candidates for hosting the workload based on these availability requirements. If intelligent enough, it should nominate queue manager instances that meet those availability requirements. Ideally, it should provide information about both the base platform and the individual queue manager instance availability to assist with the location decision. Security. Will new IDs need to be created? What level of authentication will be used for the client connections? Will you need Object Authority Manager and External Security Manager rules for the request and reply queues? For distributed platforms, will LDAP be used for authentication and authorization? A good DevOps tool can generate the standard rules or profiles for new objects and IDs would be very helpful here. Though I firmly believe that all security-related objects need to be reviewed by at least 3 groups before they are submitted: the application team, the MQ admins, and the security system owners. And by the way, the security system is often more than one group. Distributed and ZOS teams may be separate. Are there service level agreements, and how formal are they? Response time requirements can be the hardest to both pin down and comply with. As an example, if the requirement is for sub-second responsiveness, then the question needs to be asked, does the current infrastructure have the capacity? Will additional resources be required? I have seen this cause problems so often, especially when using a tool to help generate the MQ object definitions. Tools often require and rely on models, and if the template never changes, then all the definitions can end up using the same resource pool, causing contention, overload, and ultimately failure. There is also the possibility that the queue managers that meet the availability targets that we've already talked about may not be able to meet the responsiveness targets. There's always a subtle tension between availability and responsiveness. The multiple paths and shared resources are a bit less efficient than a single finely tuned path. Another consideration is how the new application will impact the existing infrastructure and applications. And your wise MQ administrator is always aware of this. Most organizations do capacity planning, relying on automated tools and experienced personnel to keep them running within acceptable levels of cost and responsiveness. Adding a new application to the enterprise and maintaining that balance is a mixture of science and art. I have spoken to many MQ admins and capacity planning people who fail to consider the details of adding an additional 5% to an infrastructure that is really approaching its internal limits. While that is a small percentage, it may be just enough to send the queue manager into a buffer pool shortage, to cause additional coupling facility traffic that impacts other systems, or filling the log files more frequently during a critical time. And it may be enough to require new processing components outside of MQ, new CICS regions, or changes to the CICS transaction to provide more instances. Experienced administrators play a critical role. While some tools learn and help anticipate when adding load to a system can take it to a breaking point, they may not know all of the environmental nuances that a wise administrator with both system and institutional knowledge possess. And those tools may not have a full picture of what MQ is doing. For example, ZAware uses JES logs and the messages there to evaluate the health of a system, but many potential MQ issues are not reported as messages until they have become truly critical. Other tools like Performance Analyzer examine the SMF data, which is also incomplete from the perspective of queue manager health because it does not include information that is only published in the JES logs. The wise administrator uses information from both the JES logs and the SMF data to predict behavior. To date, no one tool combines the two sources completely. The plans to incorporate this feedback into a DevOps tool remain to be seen. DevOps tool can help with the tedious tasks. They can also help enforce corporate policies and best practices, but they are only as good as the people who code them and the feedback tools that drive into their decision-making. The wise administrator will use these tools to help reduce the mundane tasks, but will combine that with institutional knowledge of the environment to make the best implementation decisions. Thank you.